Hey guys, I'm going to start a new tutorial series of SwiftUI framework to create native iOS application. Basically for last couple of months I'm heavily using SwiftUI framework to create a native iOS application, and I thought let's share some of my knowledge with my viewers. So to follow this tutorial series, you have to know the fundamental of Swift programming language and you must have a Mac operating system. The target audience for this tutorial series is the beginner, and today we will learn the fundamental of SwiftUI framework by creating an Xcode project, and on the way we will learn more about SwiftUI framework. So let's get started. At first we need to install Xcode in our system. I already installed Xcode in my Mac. So if you did not install Xcode yet, please download Xcode from the Mac App Store and install in your Mac operating system. Let's create a new project in Xcode. So click the file menu and from there new, then a project. So here you will see different kinds of options. So let's select the single view app and click next. So here give a project name. So in this case I am giving the project name Hello World. You must have to select the language Swift, not Objective-C, and user interface you can select either SwiftUI or storyboard, but in this case you should select SwiftUI. Okay, then click next, and then you can select where you want to save this file. So here I want to put desktop demo and click create. So a new Xcode project is created for us. So here you are seeing this Xcode window. So at the left side you can see the code, and in the right side you can see a window like this. This is called canvas or preview canvas. If I click resume in here, you see the code which is a template code written for us automatically will be previewed in here. You can use zoom in, zoom out to see the window. So maybe you can just make it a bit shorter like this, what I usually do. Okay, so in any way, if you never see this window here, then just select the editor and click the canvas. Okay, this is very important. And if you click this play button, basically the application will run in here. So you can, without running in the main simulator, you can just preview the application in here. So suppose I want to change the text in here. Suppose hello world, my first Swift UI project. So if I save this thing, and this will basically compile, and here you see that this information is showing here, and I now click the stop. And another thing is that you can use simulator here and to run the application in the simulator as well. So let's run the application in the simulator. So when we run the application in the simulator, the canvas basically automatically paused. So the simulator is running, and here we can see our text. Okay, let's talk about iOS application architecture. So when an iOS application opens, an instance of UI applications class is created, which is basically responsible to handle different events, managing UI window objects, etc. And UI window instances are not basically visible to user, rather they act like containers and hold different kinds of views. Okay, and UI application, this instance basically confirms the app delegate to pass the lifecycle methods of the application, like when application launched, if any incoming phone calls come, incoming notification, etc. And you will see then when you created a iOS application, by default the app delegate.swift file is generated by Xcode, which contains only the essential methods. So here you will see that some essential methods, but you may add other methods later when you need, like if you want to handle notification, you can do that in app delegate. But the most important method here is that the did finish launching with option. So when an app launch, this method is basically called by the UI application instance. So in here, if you need to configure your application, like initialize some data or retrieve data from network, you can do that in here. Okay. And in iOS 13, scene delegate and UI window scene are the new concept. The inter-user interface. So when you create an application, for example here, this inter-user interface of the app is represented as a UI window scene. So here in the scene delegate, and UI window scene basically confirm this scene delegate, and here in the scene delegate all the essential methods are defined, like when a scene is initialized or de-initialized, and here you will see that a window scene is created. Okay, a window scene is created, and this window scene is attached in the UI window. So UI window object is created and this scene is added in there. And here you see in the figure that this UI window basically contains a UI hosting controller, and here you see that UI hosting controller where you have to pass the root view. So here content view is the main view. So if we create different view, like we can also change the name of this content view. So if we create a new view and think that that is the main view or root view, we have to change and give the name in here. So the root view would be that main view. Okay, every time a new scene object is created in the app, this will connect to method is basically called. So suppose in a multi-window app hierarchy, how it will look like. So normally an application has only one UI application and instance, and that comes from the app delegate. So suppose in you are using iPad to create multiple scene. So this will look like this. So let's copy this thing and paste it here, another connect here. Okay, so in multi-part app it will look like this. So suppose in iPad you are creating two window of the same app. So this UI window scenes, two instances of this UI window scene will be created for multi-part application. When you create a new SwiftUI file in Xcode, there are basically two parts created. One is the main SwiftUI file, and another is another structure that comes from the preview provider, where there is a static computed property previews, that where you will see that an instance of the main SwiftUI structure is called. Okay, so if you remove this part, you see that there will be no preview in the canvas. So if you want to see the preview in the canvas, then this part is very important. If you want, you can also customize the preview part. Suppose if you want to render this preview in iPhone SE, then you can do that by providing a modifier. I will discuss modifier in later, but let's pass a modifier. So to do that, you have to put a dot and then the modifier. So in this case, I want to pass preview device, and I want to pass an instance of preview device, where I want to pass raw value iPhone SE, and save this file. You will see that the UI window is updated. Also, if you want to change some environment variable, like if you want to convert this as a dark mode or light mode, there is another modifier that is called environment, where you have to pass a key path as the parameter. So there are predefined key path like color scheme, and you can pass dark, and then you will see that the UI will be updated. Okay, so anyway, let's remove this two part. We no longer need this thing in this demo. SwiftUI views are a declarative UI component. It defines how you want the UI will look like. Views are declared as structures, and it confirms the view protocol. To confirm this view protocol, you must have to define the body property, and within the body property, you can add other subviews. So here you will see that when Xcode created a content view, it automatically confirms the view protocol, and it defines the body property, and it's by default it provides a subview, that is text view. Okay, And there are basically many built-in views by SwiftUI. If you click this plus icon here, you can see different kinds of control views here. You see navigation view, navigation link, menu view, many kinds of views with layout views and some other things. And here there are some buttons, and these are called modifiers. So for a view you can attach some modifiers. So what is basically modifier? Modifiers are actually used to customize the view. So you can apply different kinds of modifier to a particular view. So for example, for text view, we can change the font, size, color, etc., which are called modifiers. So you can think modifier as method which takes the existing view, modify that, and returns a new view. So you can call modifiers as a chain and the order matters. So let's apply some modifiers in our text view. So here when I click text, you will see that here I can see which modifiers are applied. So for example, here if I click add modifier, and there are different kinds of modifier we can apply this text view. For example, if I click this bold, you see the text become bold. Okay. Also you can apply modifier by typing. So if I type dot here, you can see that the list of modifiers are showing here. So suppose I want to change the font, apply some predefined font. Suppose I click dot, and here I can pass like headline. So you will see that it will be updated so that it will look like headline. Also change the color. So here dot, then foreground color, and then suppose I want to provide a predefined color like blue, I can click that, and you see the text become blue. So if you select text, and you can add different kind of modifier from here, but over time when you use some common modifier, you will remember that what the modifier name. So you can just directly type here, or better you can just put a dot, and then you can see different kinds of modifier here. Okay. And another thing is that if you want to add other views, okay, suppose I want to add other view, I can click plus sign, and here are different kinds of view. In the first button, suppose I want to add a button. So if I select a button here, and I have to pass an action closer. So suppose I want to pass a function, a closer. So I want to just print hello world in the console, and I want to pass the label of the button. So here I want to pass just a button. Okay, and here you will see that there is an error is showing that the function declared an opaque return type. So why is this some? I yet not describe. I will describe within a few minutes. But to fix this error, what you have to do, just cut this thing and put inside a layout view. So suppose here I want to pass a V stack or vertical stack. So if I paste this thing here, you will see that after this text the button is showing in here, and after this text I want to apply some padding. So some default padding, I just call this modifier, and you will see there are some default padding applied. Okay. So here why this error occurs when there is no V stack. So V stack is called layout view. So when you define a body property, you must have to return a single view which may contain sub view. But when there is no V stack or vertical stack, there are basically two views returns. Okay, so that's a error. So you cannot do that. Thing to notice here that we do not use any return keyword, because in Swift 5 if there is a single statement, basically this V stack is a single statement that contains a body, and within that body there are some other view, but it doesn't matter because V stack is basically a single statement, so it automatically will be returned. So we do not need the return keyword in this case. Let's run this application in the simulator. So I'm seeing the text, and if I click this button, you see here a console is showing, and here we can see the output hello world. So here the action is provided that when you will click a button, what will be shown. Okay, so this is how we can embed more views within a layout views, and there are different kinds of layout view. If you click this plus button again, you will see that there are horizontal stack or H stack, and here the item will look like arrange will be in this way, okay, horizontal way. So if I just change this to v stack to a h stack, and here if I click resume, and you see now here the views are placed horizontally, and there is another stack that is called z stack. So z stack basically that does not arrange horizontal or vertically. You can think this as a 3D concept. So if I click this plus, and here you can see the depth stack, okay, that is called depth stack or z stack. And there is a spacer which is also important, so let's convert it v stack. All right, and suppose I want to push this to view at the top. Okay, so what I can do that, the easiest way I can do that, here at the after the button I can place a spacer view. So when I click put spacer, you see it become the top. And also I can align them. So normally by default it is aligned in center, but in the v stack, and if I pass a parameter dot alignment, so you can see that what kind of parameter you can pass: spacing and alignment and horizontal alignment. So I want to pass the horizontal alignment, and I pass the leading. So you see now it is showing in the leading position. Okay, the text you see showing the leading position. And here as I use padding, that's why this text look a bit different. So for example, here I can pass only the vertical padding. So in this case no left or right side padding, so I can do that, just pass the vertical here. You see now both this text view and the button looks as the same alignment. So this is how we can create different kinds of views with layout views, etc. What is this sum keyword? So when I also started SwiftUI, I also stuck with this sum keyword, and later I learned that this is a new feature of Swift programming language, and this sum keyword represent an opaque return type. To understand opaque return type, let's create a playground and run some Swift code. So file, new playground, and this will be blank, and I want to save in my desktop demo directory and my playground the file name. So here we will learn, we will create some code. Let's define a function, func square 1. It can take a value of int type, and it can return an integer type, and it will return val into 2. And as there is a one statement, I just omit the return keyword, and let's call this function square 1. Square 1 and pass the value suppose 2, and let's run this here, and I can see the output in the right side. So it is showing 4. So basically when we define a function that returns a result, we must have to define what the result type will be. So in this case we define the return type is integer. Okay, let's define another function square 2, which will take a double value and return a double value type result. Okay, so let's call this square 2 and pass 2.2. If I run this, I can see here 4.4. So both of these functions basically return concrete type. So this function returns integer type, this function return double type. So what is then opaque return type? So opaque return type basically defines that instead of specifying a specific return type, we can allow that a function can return any type as long as the function conforms to a specific protocol. So there is a protocol named equitable protocol which is used to compare the values. So if we want that we want to use that protocol as a opaque return type, we have to first put the sum keyword, then the protocol name. So here sum keyword and the protocol name. And if we run this program again, you see everything is working fine. Okay, so in this case both of these function returns opaque return type. So that means there are no concrete types. So if someone sees this function signature, they can understand that this function return a equitable type, but doesn't know that what the value will be. Okay. So the only thing know about this type is that they conform to the equitable protocol, and we therefore know the capability of the type but not the actual type. So here in the program you see that when the view is created, there is a body property which returns a opaque return type of view protocol. So basically we can return a layout view, that is vstack. We can return a concrete view, that is a text view, which a different view, or we can return button view. Okay, so we can return different kind of view anytime. So there is no concrete return will be happen in here. So for this reason we must have to use the opaque return type for the body, so that we know that this body property can return any type that conforms to the view protocol. Okay. So I hope that you understand some basics of SwiftUI in this tutorial. In my following tutorials, I will discuss more about SwiftUI to create beautiful native iOS interface using SwiftUI. So thanks for watching, and I hope to see you again in my next video.